Okay, let's do this lab called Introduction to Solutions. In this lab, we're going to make up 4 solutions, A, B, C, and D. And the first 2 are going to use sugar, which is better known as sucrose. Formula C12H22O11. This is your regular table sugar. The other one is sodium chloride, better known as table salt. All right, it says to put 15 milliliters of water into test tubes and add the specified grams of each. 15 milliliters of water into each. There we go. Solution A then is to have 0.3 grams of sugar. So we'll put our weighing board on here, hit tare or 0, and add 0.3 grams of sugar. That is not a lot. There we go. 0.31, 0.32, good enough. Next we have to add that to the first test tube. All right, we'll take our weighing board here and pour it right in. Right there's solution A. Solution B is going to take 4 grams of sugar. All right, 3.91, good enough. We'll add that then to test tube B. Test tube C has 0.3 grams of the salts. Test tube C, 4 grams of salt. All right, we'll put a cork on and shake them all up. And here we are, our 4 solutions, A, B, C, and D. Now, let's look at some questions here. Using the following definitions, solute and solvent. Solute, whichever substance there is less of, is dissolved and is dissolved. And for solvent, the substance where there's more of and does the dissolving. So in the case of solution A, the solute is sugar. And the solvent is water. Now that's going to be the same for the other solutions as well. So the solute, sugar, and in the other ones, the solute, salt. And the solvent is water in every case. The stuff that does the dissolving. All right, question. When you were making the solutions, what did you notice as the solute dissolved in the solvent? Now, taking a look at this, in solution A and C, the solute disappeared, and in B and D, some of it is left on the bottom. We could then say this. In solution A and C, all the solute dissolved. In solution B and D, some of the solute did not dissolve, and some did. Question 2 says, what did you do to make the solute dissolve faster? What else could you have done to help it dissolve? To make it dissolve faster, we shook it. What we could have done is heated it, and it would probably dissolve faster as well. We could then say this. You shake it to make it dissolve faster, and you heat it, it could also make it dissolve faster, but we didn't do that. For this next part, use the following definitions to determine if each solution is unsaturated, saturated, or supersaturated. Unsaturated means that the solution that has less solute
dissolved in the solvent than is possible. There's still room for more to be dissolved. Saturated means that you have the maximum amount of solute, and supersaturated means you have more than the max. You usually will have to heat the solution to make that happen. So solution A and B, solution A is clear and solution B has some stuff on the bottom. So the second one then is saturated because some stuff dissolved, but some of it just sank to the bottom. In the first one, all of it dissolved, so you probably could have dissolved more. So let's say that solution A is unsaturated and solution B is saturated. For solution C and D, same thing. C is clear and could probably dissolve more, and D is got some stuff on the bottom, so we're saturated. In the next section, it says, using the following definitions, determine which solution is more dilute and more concentrated. Now, dilute means that the solutions have a small amount of solute per solvent, and concentrated means they have a large amount of solute per solvent. So solution A and C have a small amount, so they are dilute solutions. Solutions B and D are saturated, therefore they would be considered concentrated solutions. However, concentrated does not necessarily mean that they are saturated, but if they are saturated, they usually would be concentrated solutions.
Next, it says, carefully take your 4 solutions to the front of the room to the conductivity probe, rinse the probe, dip it into each solution, recording the conductivity of each.
This is a conductivity probe. It measures conductivity in a unit called microsiemens per centimeter. We'll put it in test tube A, 496. Rinsing it off. Test tube B, 389. Test tube C, much bigger, 28,645. Test tube D, 29,420.
All right, then it says, is it an electrolyte or a non-electrolyte? So the ones with the low numbers we're going to say are non-electrolytes. And the ones with high numbers are electrolytes.
All right, for the last question, it says, at your lab bench, locate the small flask with a solution in it. Give it a swirl. All right, let's take a look at that. All right, this is a solution of oil. All right, I'm going to swirl it up here. Let's see if we can see what we got. It's got little globs of stuff. That is food color. And it doesn't look like the stuff actually dissolves. It's very distinctly heterogeneous. This is a solution that we call let's see if we get a good shot of it here, a solution we call a suspension. If we let it sit for a while, that stuff will sink to the bottom and separate from the liquid, a suspension. All right, that differs from the ones we made before, which were solutions, which were heterogeneous or homogeneous in nature. All right, the last thing is to clean everything up, and then we're done.